Hello, Algebra 2. Today we will be looking at section 5.6, remainder and factor theorems. So we're going to start off with something we call synthetic substitution. And this is another way that we can find the y value of a function when we substitute a value for x. So for example, suppose you're given f of x is equal to this function here. And what I need to find now is f of 3. So I know that there are several ways that we can do this. One is by direct substitution. Direct substitution is when you take 3 and you substitute it for all the x's in f of x. So for example, substituting in x here, here, and here, f of 3 will be 3 times 3 cubed minus 6 times 3 squared plus 3 minus 11. So f of 3 will be 3 times 27 minus 6 times 9 plus 3 minus 11. And finally, when you simplify, f of 3 is equal to 19. All right, now we're going to do the same thing, but long division. So what we're going to do is this. All right, we're looking for f of 3. So what I do is I take this number 3 and I write it as a binomial and I say x minus 3 and I get that. So now what I'm going to do is I'm going to divide. Here is my f of x and this is my x minus 3. So we're going to do long division. All right, so we have the first term over the first term equals 3x squared, and I put that here. I multiply 3x squared times x gives me 3x cubed. 3x squared times negative 3 is negative 9x squared. Now I'm going to subtract. 3x cubed minus, this is a cube, minus 3x cubed goes away. Negative 6x squared minus negative 9x squared, so that's going to be 3x squared. I bring down the x. So again, 3x squared over x gives me 3x. So here I have positive 3x. Now I multiply. 3x times x is 3x squared. 3x times negative 3 is negative 9x. Now I'm going to subtract. Minus plus here. This goes away. So I have 10x minus 11. And lastly, 10x over x is 10. So I have plus 10. So I get 10x minus 30. I know you don't see what we're doing, but you will in just a second. I'm going to subtract. And look at that. This goes away. And I have a remainder of 30 minus 11, which is 19. And oh my goodness, that's exactly what f of 3 is. So here's another way to find f of 3. It's the remainder when we do long division. Now let's do the same thing, but with synthetic division. This method is called synthetic substitution. So again, we're going to take that same value of 3 and we're going to put it here, and now we're going to work with synthetic division. So the 3 comes down, multiply by the outside 3, we get 9. You add, you get 3. Multiply, you get 9. Adding gives you 10. Multiply gives you 30. Remainder is 19, and there you have it. f of 3 is equal to 19. All right? So this is finding the value of a function by synthetic substitution, whereas here it was by direct substitution. You should know the difference between the two. So what we notice is that the value of f of 3 is the same using all three methods. So whatever the graph looks like, when x equals 3, f of x is 19. All right, so that brings us to what we call the factor theorem. Now, before we go to the factor theorem, let's think about dividing regular numbers. So suppose I wanted to divide 61 by 4. All right, 4 goes into 61. I know it's 15. 15 times 4 is 60, and I have a remainder of 1. Well, now, what if I wanted to divide 60 by 4? 4 goes into 6 once. I have 20. 4 goes into 5. 25 times 20. The remainder is 0. All right, so what does it mean that the remainder is 0 here, but the remainder is 1 here? Well, in this case, the remainder is 0 because 15 is a factor of 60. All right, so when we do polynomial long division or even synthetic division and we get a remainder of 0, that means that what we divided by is a factor of the polynomial. And the quotient is called a depressed polynomial. Yes, that's funny. It's a depressed polynomial. All right, so let's take a look at this. It says determinant of x minus 3 is a factor of this. Then find its other factors, and so on and so forth. So let's divide, and if we get remainder 0, we know that x minus 3 is a factor. All right, I'm going to divide using synthetic division. 1, 4, negative 15, negative 18. 1, 3, 7, 21, 6, 18, 0. Okay, because the remainder is 0, x minus 3 is a factor. Now, that means I can write this like this. F of x is equal to, from here, I say x minus that number 3. And here, I get the depressed polynomial. So it's going to be, I had started off with x cubed, so now it's going to be 1x squared plus 7x plus 6. And now that's my f of x. What I do next is I need to factor everything. So f of x is equal to x minus 3. And now I factor this. It's x plus 6, x plus 1, and there you have it. Okay, next. Given a polynomial and one of its factors, find the remaining factors of the polynomial, and then we're going to have to graph this one. All right, so here we go. Here's x minus 1, so I put a 1 here. My coefficients are 1, negative 6, 11, negative 6. 1 comes down, and I have 1, negative 5, negative 5, 6, 6, 0. So yes, it is a factor. If it tells you that you're given one of its factors and you do this process and you don't get 0, then you must have done something wrong in the division. So you have to go back and check your work. All right, so here, f of x is equal to, from here, I get x minus 1. Then from here, it's the depressed polynomial, which is x squared minus 5x plus 6, x minus 1, x minus 3, x minus 2 when we factor. All right? So this is the factored form. Now let's graph this. In order to graph, I need the zeros. Well, the zeros from here, it's x equals 1, 3, and 2. All right, so let's see here. At x equals 1 and 2 and 3, there are zeros. Now, here, the leading coefficient is 1 and the degree is 3. Remember, when the degree is 3, it's an odd function, meaning one side of the graph is up and one side of the graph is down. And because this is positive, I know that the right side is up and the left side is down. You can check 5.1 and 5.2 for this. So I know that here on the right side, and on this side, it's going to go down. And the y-intercept is -6, right? So the y-intercept, if I plug in x equals 0, 0, 0, the y-intercept is -6. So that's here. All right, so that means the graph comes up like this. Now it has to come back down to cross the 0, come back up to cross the 0, and goes up. Now, I don't care how high or how low your minima and maxima go, as long as it's going down on this end, it's going up on this end, and you cross all of the zeros, okay? So this homework is due on Monday. This is number 29. The parentheses got misplaced, and I will see you guys on Monday. Thank you, everybody.